All right, well, we went over tests, and students did pretty well. We did have one perfect test. Michael was perfect on test 9, so hopefully you did well if you're watching. And we're going to change gears, though. So the calculators are away. No more calculators. Do you need some water? You have water. Okay. Calculators are away. We're done with calculators probably for the year. We may get them out again a little bit later on, but for now, we'll leave those there. We're back to our big textbook. So the little supplement days are over. Now you have to lug a big book to math class. And open up, if you would, to page 250. Page 250. And we're going to be spending the next chapter talking about probability. The odds of something happening. How many of you filled out a bracket for March Madness? Any of you guys fill out a bracket? Okay, you've got a lady that filled out a bracket. There we go. Yeah, my bracket was trashed on the first day. I didn't survive the first day. I'm like, yep, this is over. And so that was sad. I'm not a huge college basketball fan, so I filled out the bracket for the fun of it. I was more into it when I was in high school and had more time. Now that I have less time, I make time for football. I don't make time for basketball. Sorry, basketball people. Yeah, I enjoy it, but not that much. So anyway, my bracket's busted. But the probability of winning. I'm in a group of some men in our church and some friends in the area. There's only 10 guys in the group, so my odds of winning are still 0%. But anyway, my odds of winning going into it at least were a 1 in 10 chance that I could win this thing, right? Whereas when I filled out my ESPN bracket, well, I mean, there are, 40 million brackets-ish, something like that on ESPN? Yeah, the odds of me winning the ESPN bracket competition are so insanely low. But then you join groups, right? So I'm in a couple, Notre Dame fan groups, which none of us care about basketball that much because Notre Dame's definitely not in it. But there's a group of Notre Dame fans that's only 115 people. Well, I got a lot better odds in that group, right? 1 in 100. Still no chance of winning that one either because that bracket's busted too. I even made the brackets different, so I'm like, maybe one of them will do well. No, they're both bad. All right, so anyway, but probability is just the odds that something takes place. Well, as we talk about probability, Ben, one of the things that we need to do is have an understanding of how many total outcomes exist. If you see that term in bold there, this term outcome. An outcome is a possible result. If you'll mark that term, an outcome is simply a possible result. Every possible result, marking it there in your book, Ben, every possible result that could take place, there as we're on page 250, is called an outcome. The book gives a couple of illustrations. This first one that's mentioned doesn't have a picture or anything with it. Says, how many outfits could you make from 5 pairs of slacks, 6 shirts, and 4 ties? How many different outfits could you make? Well, let's see. The 1 pair of slacks could go with all these different shirts, and then you could pair all of those with another tie. You could make a whole lot of different outfits from that. I would question why only 4 ties. I mean, those who've been watching my YouTube videos know I've got a lot more than 4 ties. In fact, I had some people who watch my videos, they actually mentioned to me, they remember which video lesson they're on based on, yep, you wore that tie last time. So we're going to watch the next video. So anyway, yeah, I'm like, 6 shirts sounds about right, 5 pairs of slacks sounds about right, only 4 ties, bless his heart. But anyway, there's still a lot of outfits you can make with that, right? Now, that's assuming you either are colorblind or have no fashion sense, or somehow every tie and every shirt go with every pair of pants. And that's not the case. But anyway, I digress. There's a lot of different outcomes. They give you another one, and this one they gave you some pictures. Let's suppose you go to this particular dinner, and as you provide the dinner, you want to have either an Asian salad or a house salad for everybody. You've got steaks, you've got fish, you've got lasagna. They can pick one of those. And then because you're a health nut and clearly not concerned with carbs, wanting potatoes or something like that to go with steak, for instance, you've got broccoli, peas, or green beans because the salad just isn't enough vegetable for you. How many of you love vegetables? Okay, a couple of you. How many of you no? Like if my mom didn't make me eat them, I would not eat them. Luciana said, how many are like, I eat them, they're good for me. I don't really care too much, but it's not my favorite part of the meal. Yeah, anyway, yeah, vegetables never one of my favorite things. They don't have the good taste to them. I know they're good for me, so I eat them. But anyway, how many different meals could we make? Well, one way you could go about this, the book says, is you could make an exhaustive list. And so what they did was they used the letter H to mean a house salad. They used the letter A to mean an Asian salad. They use S to mean steak, F to mean fish, L to mean lasagna, B for broccoli, P for peas, and G for green beans. If you look at the top of the next page, they list out all the different options that one of their dinner guests could make. And Jalen's making a great face right now. I wish I could catch it on camera. It looks something like, well, I couldn't really do it justice. But anyway, it was a great face of, that's a lot of work. How many of you are thinking the same thing? Ah, that's a lot of work. So then there's another way you could do this. Look at the little fast factor. You could make a tree diagram. You'd be like, okay, let's say we start with a house salad. Well, house salad people could get a steak or fish or lasagna. And if you've got the steak, then you could do broccoli, peas, or green beans. And you could do that for the fish. You could do that for the lasagna. How many of you are thinking that's even more work? Yeah, I'm in the same boat. I'm lazy. I don't want to do either of those things. There's a better way. It's something called the fundamental counting principle. Mark this down. You see that in bold there. The total number of options that you can make, total number of outcomes. And I think I'm not recording anymore. Oh my.
That is disgusting.
It's just the thought of, okay, I think we're back up. Maybe the camera didn't catch that. Maybe it did. We just don't know. We won't say who that was for protect the guilty here. Anyway, fundamental counting principle. Write this in all caps off to the side. Multiply. Multiply outcomes for each event. Multiply. Write that in all caps. Multiply outcomes for each event. Write it sideways. Turn the book sideways and write it. Yeah, that'll fit better. Multiply. And then the rest of it, you don't have to put all caps. Outcomes for each event. Do you realize that when the guest comes to the dinner party, they've got to make a choice. Which salad do I want? Then they've got to decide which entree do I want. Then they've got to decide which vegetable do I want, right? Do you see that there are 3 different choices they have to make? Each of these choices is called an event. So we've got event 1, that's the salad of their choosing. We've got event 2, that's the entree of their choosing. And then we've got event number 3, that's the veggie of their choosing. They call it a side. Let's be real, it's a vegetable. Well, the question is, how many salads are there, class? 2. There are 2 salads they can choose. How many entrees are there? 3. How many vegetables are there?
3.
All we have to do, what's in all caps, class? Multiply the outcomes for each event. 2 times 3 times 3 equals 18. There we go. Some of you got warmed up earlier. Isn't that easier than making out an exhaustive list of all the possibilities or even making a blasted tree diagram? That's pretty easy, right? Look at the next page. Look at the top of the next page. Let's go back to that, and Michael, we're missing you today, by the way. But Michael is apparently the person with 5 pairs of slacks, 6 shirts, and 4 ties. How many different ways could he show up at church? Here's maybe an illustration. Let's suppose the power goes out Sunday morning. And Michael's feeling around in the dark, and he's like, okay, I feel pants, I feel shirt, and there's a tie. And he just grabs them blind and puts them on while it's dark. And he shows up at church. Yes, this should be interesting. Well, how many different ways could Michael show up? Well, there's 5 pairs of slacks. That's one event, right? 5 outcomes in the first event. Then his next decision is, well, not really a decision because he's doing it blind, his shirts. How many shirts he got, class? 6. His choice of shirt is an event. There are 6 outcomes. And then for the ties, we said there are 4. 5 times 6 times 4 equals 120. There's 120 different ways Michael could emerge from his bedroom. And there's 120 different responses his mom could have when she sees him. When she strikes the candle, like, ah! My son, what happened to you? Anyway, maybe she does that I'm just picking on you, Michael. We love you. Anyway, does that seem to make sense? Or doesn't that seem like the easy way to do this? The key is you have to recognize every single choice. You have to figure out how many different ways could that first choice go. Does that make sense? All right, so let's look at some example problems here on page 252. And read that first problem for us, if you would, right there above the picture of the Dalmatian and the gray kitty cat. Any animal lovers in here? You just love animals. Ben loves animals. Ben, read number 1 about Jennifer.
Jennifer wants to adopt a dog and a cat from one of the 3 animal shelters in her area. Find the total number of possible outcomes at shelter 1, shelter 2, and shelter 3.
All right, so she goes to shelter 1, and there's only 2 different kind of, this is very unrealistic, but there's only 2 kinds of dogs at shelter 1, class. At shelter 1, all they got is either a boxer or a Dalmatian. All right, and then she goes to look at the cats that they have. They got a few different kinds of cats. They've got Persian cats, Himalayan cats, and Siamese cats. All the Asian cats. All right, so she goes to shelter 1, and she wants to pick both a dog and a cat. Event 1, class, is her choice of dog. Is her choice of dog. Event 2 is her choice of cat. How many choice of dog does she have at the first shelter?
2.
And how many choice of cat?
3.
3. So when she, at shelter 1, so when she comes out of shelter 1, if she chose both a dog and a cat, how many different combinations of dog-cat could she come out with, class? 6. Everyone see that? Now at shelter 2, how many different combinations of critters could she come out of shelter 2 with, class? 4, because there's 2 dogs, 2 cats. Go to shelter 3. How many different ways could she come out of shelter 3? 8. 2 dogs, 4 cats, we just multiply. Make sense? All right. Now let's drop down to number 2. And read number 2 for us, Kirsten.
Crystal River Christian School is holding elections for class officers. Find the total number of possible outcomes for A, the senior class election, and B, the junior class election.
All right, so when the seniors go to vote, they're first going to vote for a president. Well, how many people do they have to choose from, class?
2.
2. They kind of narrowed it down. It's going to be one of those 2. Then they also have to vote for a secretary. Class, there are 2 choices for event number 2. 2 outcomes for event 2. And then for event 3, treasurer, there are 3 outcomes. All right? So what do we have to multiply, class? 2 times 2 times 3. How many different ways could the senior class election come out, Kirsten? 12 different ways. Do we see what we're doing? Now at your seats, you figure out how many different ways the junior class election could go. At your seats, figure out how many different ways could the junior class election turn out. And Joel, what you got? 36. How many had 36 different ways that election could pan out? 4 times 3 times 3. All right, drop down to number 3 and read about Gail for us, if you would, Elaine.
Gail will join 2 school sports teams. In the fall, she can join either the soccer or volleyball team. In the spring, she can play softball or run track.
All right, so the question is, how many different ways could she pair together her athletic experience at this school? Well, what you got here, Elaine? 4. If event 1 is the fall sport, there's 2 outcomes. Event 2 is the spring sports, there's 2 outcomes. 2 times 2 is 4. How many thinking 4? All right, Joel, read number 4 for us.
Joel exercises in the morning and practices in a team
participates
in a team sport in the afternoon. In the morning, he can run, bike, or swim. In the afternoon, he can play lacrosse or football.
All right, so 2 different events. The first event, class, is his morning exercise. It might be a run, his morning exercise. And his second event is the team sport, right? His first event is his morning exercise. His second event is the team sport. All right, how many different outcomes for the morning exercise, Ben?
4. No, 3.
3, right? Run, bike, or swim. And then his afternoon sport is going to be how many different outcomes?
2.
2, the lacrosse or football. So, how many different outcomes could Joel have to structure his fitness experience each day?
6.
6 different ways he could put that together. All right, how many thinking 6? Feeling pretty easy, not blowing anyone's brain. First day off spring break. We're really getting the 4th quarter going here. Everybody feel pretty good about this. All right, number 5. Read that for us, Jalen.
Softball players Softball players may order fitted or adjustable caps. Caps are either black or white and include team name in one of the following colors: red, gray, or pink.
All right, now when I went to school, the softball players all had to have matching hats. But this school's a little bit more open-minded. Hey, your choice. Now there are actually 3 different events. What are the 3 different events in this problem here, Jalen?
Fitted or adjustable.
Fitted or adjustables, that has how many outcomes? 2. So the way the cap fits is one event. There's 2 outcomes. The next event
is either black or white.
So the color of the cap, right? And there's 2 options there. And then the third event is
The color to me.
The color of the name that's on the cap, presumably embroidered on there, and there's how many choices there. So how many different ways could a girl get her softball cap fitted for, or made for her, Jalen? 12 different ways. How many also had 12 different ways? By the way, you notice it said to make an exhaustive list, and we didn't do that. You know why? Because we are lazy. Absolutely. Move over to number 6, top of the next page, and read number 6 for us, Griffin.
Each side of a cube is a different color. Pink, red, blue, yellow, green, and black. The cube is rolled blank times.
All right, so this is, how many have ever played like Candyland or something like that? Usually Candyland is played with cards, right? You pull the card and it tells you, what to do. Well, let's imagine they gave you a die instead. You know what dice are, right? You roll the dice. Well, instead of having numbers on the dice, there's colors, and it's just a single one, so it's called a die. So there's different colors on it. You roll it. Let's just assume that's how this goes. Well, if you roll a die just once, how many different outcomes are there, Griffin?
6.
6, because there's 6 sides to the die, right? That's a single event of 6 outcomes. There's one way that could go. But let's suppose you're going to roll the die twice. Each time you roll it, there's how many different outcomes, Griffin?
6.
So how many total outcomes could there be if you roll the die? Twice. You roll it.
12.
You roll it again. Ooh. Bryson? Okay, so let's say you roll it the first time, class, and you could get, let's just say you got red. Well, that's one of 6 different outcomes, right? And you roll it again. Let's suppose you wanted to get another red. Well, that's again one out of another 6 outcomes. What are we supposed to do with our total number of outcomes each time, class? Multiply. So, Griffin,
Wait.
first roll, there's 6 outcomes. The second roll, there are again 6 outcomes, but between the 2 rolls together, like red and red is not the same as red and orange, which isn't the same as red and yellow, which isn't the same as yellow and red, right? How many different outcomes are there from 2 rolls together? Bryson? 36, because we're going to multiply the 2 6s together. So if you roll the die twice, there are 36 different ways the 2 rolls combined could come out. Does that make sense? Well, let's suppose, letter C, we roll the die 3 times. Now, red, red, red could happen, right? But the odds of it are getting really small that you would get 3 reds in a row, aren't there? That's because on 3 consecutive rolls, how many different outcomes could there be? Okay, Griffin? Figuring it there at your seat. The rest of you doing it as well. Looks like Griffin's on the right track. The joy of sitting on the front row, I can see exactly what he's doing. And Griffin has
216.
216. How many also had 216 different outcomes? So you realize then the odds, if you will, of rolling red and then another red and then another red, unless it's loaded die, is 1 out of 216 chance. That's just one possibility out of 216. Now let's suppose you're trying to roll the rainbow, as opposed to taste the rainbow, which are the Skittles. Anyway, but you're trying to roll the rainbow, okay? And you roll red, then you roll orange, then you roll yellow. Well, again, that's one of the 216 different ways you could roll when you roll 3 times in a row. Does that make sense? So the odds of rolling red, yellow, red, orange, yellow in that order is 1 to 216, because there's 216 outcomes. Well, now, let's take it a step further. 4 rolls in a row. How many different ways could those 4 rolls together wind up? And we'll get this from Luciana when she's got it.
144.
Ooh, no, Corey.
1,296.
1,296, because the first roll, 6 outcomes. Second roll, 6 outcomes. Third roll, 6 outcomes. Fourth roll, another 6 outcomes. 1,296 different ways your 4 rolls could go. Everyone see that? Every time you roll, it's just another times 6. Make sense? All right, let's go to number 7. And Bryson, read number 7 for us. Number 7, right next to number 6.
My fault. The street vendor sells 5 different flavors of gum, 8 different
Beverages.
and 10 different candy bars. A customer purchases.
All right, so the question is, how many different outcomes could happen? So if a customer walks up to the vendor and is like, hey, I want a pack of gum and a drink. Well, how many different ways could a pack of gum and a beverage turn out? Well, the first event is the pack of gum. The second event is the beverage. How many different ways could a pack of gum and a beverage be sold to this customer? And let's go back to Bryson for this first answer. Call it when you've got it.
140.
How much?
140.
140? Okay, you're multiplying all the numbers together. This person isn't buying a candy bar, right? So you multiplied to 10 because there were 10 candy bars. This guy's not buying a candy bar, though. So we only need to take care of the gum and the beverage, which would be 40. Does that make sense? Okay, 40 different ways that the customer could purchase a pack of gum and a beverage. Let's suppose the customer, now, class, we have to assume here, by the way, the vendor has lots of each beverage, right? It's not like he's only got one Dr. Pepper and one Sprite. So, like, he's got lots of Dr. Peppers, lots of Sprite. So a customer could buy 2 Dr. Peppers if he buys 2 beverages, right? All right, so customer walks up, wants to purchase 2 beverages. How many different ways could 2 beverages be purchased by a customer? We'll get this from Luciana.
16.
What do we have to do with the outcomes?
Multiply them.
So the first outcome is the first beverage. There's 8 different ways the first beverage could go, right? The second beverage, there's another 8 different ways. And what do we have to do with those outcomes?
Multiply.
So how many different ways could they purchase 2 beverages?
64.
64 different ways. How many got 64? All right, does that make sense now? Right, it's not that one choice is 2 and one choice is 8. No, one choice is 8 different beverages. The next choice is another 8. Whew. Letter C. Letter C, this is a big one. Somebody walks up, buys 2 beverages and 2 candy bars. How many different ways could these purchases go? A big number here. Big number. So the odds of getting a Reese's Nutrageous, a Sprite, a Dr. Pepper, and a 3 Musketeers is only one possibility out of how many total different ways a customer could order these things. Corey?
640.
Oh, you only got 1 candy bar. You got 2 candy bars. So you got the first beverage, 8. Second beverage, 8. First candy bar, 10. There's another candy bar, though, that's another 10. So multiply by 10, you get?
6,400.
There we go. How many had 6,400 different possible ways a customer could order? All right, letter D. Person buys a pack of gum, a beverage, and a candy bar. They get 1 of each. They get 1 of each. How many different ways could these be purchased? And we'll come over to Ben for this one.
140.
140. So the gum was how many possibilities?
5.
5. Then they're going to purchase a beverage. That's
8.
8. And then they're going to purchase a candy bar.
10.
10. 5 times 8.
40.
And then we multiply that by 10. Don't put a 1 in front. Just move the decimal 1 place and get
400.
400 different ways. If they got 1 of each item, 1 type of each item, they would end up with 400 different ways they could buy those. How many had 400 here? All right, questions on number 7. We start to make a little bit more sense as we get into more complex problems. Still following? All right, number 8. A 2-digit combination lock. And each digit can be anywhere from 1 to 3. Now, I'll be honest, I've never seen a 2-digit combination lock. Any of y'all ever seen a 2-digit? You know the kind of like a briefcase where you thumb the little numbers or whatever, or sometimes, you go, any of you ever like been with your parents when they've been buying a house, they walk up, there's a little realtor box sitting there, you have to thumb the numbers on the pad. Anyway, it's only 2 digits, and the number is either somewhere between 1 and 3 on the first digit and somewhere between 1 and 3 on the second digit. How many different combinations can you make with that? How many events do we have, class? 2. Each digit is its own event. How many options are there for the first event, Kirsten?
2.
So the first digit is either 1, 2, or 3, right? So that means there's how many outcomes for the first event?
3.
There's 3. And then the next digit is the next event, and once again, there's only 3 options. So how many different combinations can you make if you only have 3 digits to choose from, and there's only 2 digits there?
9.
9 different combinations. Well, let's suppose that this combination lock gives you options from 1 to 4 for each of the 2 digits. from 1 to 4 for each of the two digits. Well, now, Kirsten, you have how many different combinations?
4.
Well, there's 4 options for the first digit and 4 options for the second digit, right? The first digit's either 1, 2, 3, or 4. Second digit's, again, either 1, 2, 3, or 4. So that means there's 16 different combinations. By the way, do you see why they don't do it this way? Because let's be real. If you wanted to break in and there's only 16 combinations to try, how long does it take you to try 16 combinations? You try the 1 with the 1. Nope. 1 with the 2. Nope. 1 with the 3. Nope. 1 with the 4. Nope. 2 with the 1. Nope. 2 with the 2. Nope. 2 with the 3. There it is. I'm in. You know, like you only have to try up to 16 times. You're going to get it eventually, right? Let's break from the problem here. A real combination lock, 4-digit combination lock. How many digits are on the little dial?
Like
A normal combination
9.
lock.
Oh.
0 through 9
0,
is actually how many numbers?
10.
10, right? So the first little dial that goes from 0 to 9 has 10 different possibilities. But then there's a second one that again is 0 to 9 class. That's another 10 possibilities. The next one's another, and the next one's another. And what do we have to do to get the total possibilities? So 10 times 10 times 10 times 10. How many different ways would you have to try that combination lock before you break in? Jalen? 10,000. All right, do you really think you have time to try 10,000 different combinations?
Yeah, sometimes.
Probably not. And that's why you're going to lose track of which combinations you've tried too, right? You're not going to do it. And they know that. That's why bike lock combinations, briefcase combinations, realtor pad combinations, they feel pretty safe with 10,000 possibilities. They feel like that discourages you. But if it were only 9 or 16, let's go to letter C. Now they're only 2 digits still, 1 to 6 each time. 1 to 6 each time. Joel, how many possible combinations are there?
36.
36. What about 1 to 9? So they're not losing 0. It's just 1 to 9, but there's still only 2 digits. It's getting a little more frustrating for somebody who's trying to break in, but it's still not too bad.
81.
81 combinations. All right, do we start to see how to use this counting principle? All right, go to number 9. Go to number 9. Ooh, interesting. All right, read this for us if you would. Kirsten.
A PIN code has a number, letter, number sequence. Each number can be a single digit from 1 to 9. The letter can be any of the 26 letters of the alphabet.
All right. Okay, so this is going to be a 1 through 9. This is going to be an A through Z. This is going to be a 1 through 9 class. How many different numbers could be in that first spot of the pin?
10.
Well, 1 through 9 is only 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? The 0 would make it a 10th. Okay, but it's only 1 through 9. How many letters are there in the alphabet class? 26. And they, by the way, do you see how they dropped it in there just in case you forgot that from your youth? How many remembered it though? You're like, I remember 26 letters. How many books in the New Testament?
66. No, not.
That's the whole Bible.
27.
27 in the New Testament. How many in the Old Testament?
400.
39. And the whole Bible is 60. Anyway, all right, so 26 letters in the alphabet, though, that's this there. And then how many numbers in the last digit of the pin?
9.
9 more. What are we going to have to do, class? So how many different pin codes can we make? The idea being that this is going to protect your account security. And we got a big number coming up. And Bryson's got it.
2,106.
How many have 2,106 different combinations for the pin? Let's think about your lockers. I'm going to break from this. Let's think about your locker locks. Have you noticed how many different numbers are on the dial?
30.
36.
40 total. It goes from 0 to 39 on the dial. So there's a total of 40 different digits that your first number could be. So there's 40 for the first number. Then for the second number class, there's another 40. Although technically, you're never going to repeat the same digit.
So 39.
So technically, one could argue 39, but let's just say 40. And then for the next digit, another 40. Right? Now, again, technically 39, because you wouldn't repeat what you just repeated. But the math works better this way, okay? Because I don't want to multiply 39. So let's hang the zeros. And let's multiply 4 times 4
16.
times 4.
32.
No, 64.
64. if you could repeat, and it's going to be a little smaller than this because technically these would have both been 39s, there's about 64,000, even with the 39s, there's over 60,000 different combinations. In other words, the only way somebody gets your combination is if you tell them, or you let them see your paper, or you let them watch over your shoulder. So in other words, it's not my fault if they steal your stuff. Right? It's your fault. Anyway, that's just while we're on the topic of security and pins and combinations and stuff. Let's go to number 10. Joel, read number 10.
3 representatives one from each class will be selected from Bellamy Junior High to attend the government conference. The junior high classes have enrollments of 25, 40, and 36.
All right, so apparently it's like a middle school setup where there's 6th, 7th, and 8th grade all together. So it looks like there are 25 6th graders, 40 7th graders, and 36 8th graders. Or maybe the numbers are the other way around, but there's that many kids. One kid from each class is going to get picked to go to this conference. The question is, how many different ways could these 3 representatives be chosen? How many different groups of 3 could be sent to the conference? At your seats, find the answer. Some of you are like, we need our calculators back. No, we're helping to keep your brains sharp here. Got the answer. All right. Jalen's got it. Looks like Corey got it back there. All right. A few more people looking finished. All right. Now the best way is to multiply them in order because 25 times 40 comes to a nice easy 1,000, doesn't it? Mm-hmm. And it's so easy to multiply 1,000 by 36, class.
36.
Isn't that crazy? 36,000 different groups of 3 that could be sent to this conference. Number 11, read that for us, Elaine.
T-shirts are manufactured with different sleeve lengths: short, long, 3/4, or sleeveless. Colors: red, white, green, blue, yellow, pink, or purple. Patterns: solid, striped, polka dot, or plaid. And neck styles: round or V-neck.
All right. Obviously, what I'm wearing right now, long sleeve. What Luciana has on, short sleeve. How many have seen those 3/4 length sleeves? They come down past the elbow. The baseball tees would have that. And then sleeveless. Okay, so there's 4 different sleeve lengths. How many different colors do we have here, class?
7.
7 different colors. How many different patterns?
5. 4.
I'm saying 4. Solid, striped, polka dot, and plaid. And then how many neck styles?
2.
2. At your seats. Figure out how many different kinds of t-shirts this company makes. It's a lot of t-shirts. How many different kinds of t-shirts does this company make? So a customer orders one shirt at random. The odds of a particular shirt being the one he chooses is 1 out of how many total? Feverish multiplying. And Joel, what you got?
224.
How many have 224 different styles? Good, we have to multiply those numbers together. Look at number 12. Read number 12 for us, if you would, Jalen.
A company manufactures paper, plastic, and foam plates. The plates are square or round and are produced in the following colors: red, green, pink, purple, and white.
All right, and so a wife sends her husband to the store. Guys, picture this. Hey, hubby, I need you to pick out some disposable plates. And you go to the store expecting disposable plates. You grab a pack, and suddenly you're like, there's foam and paper and plastic. I wonder which one she wants. And then she's like, there's all these colors. And then, does she want the square ones or the round ones? 3 different events, 3 different choices have to be made. Now, hopefully you're married to the kind of wife who really doesn't care. She just wants a pack, so you find the cheapest and you bring them home. But maybe you're married to one of those high maintenance types who has something very specific in mind, but she didn't give specific instructions. And she's like, dear, you've seen those guys at the Walmart, haven't you? They on the phone with their wives. I've been there before. And it's like, which one did you want? So anyway, at your seats. How many different choices does this poor husband get faced with at the store, trying to figure out what he's supposed to get? How many different choices are before him? And therefore, he will enlist more direction. And Jalen, what you got? 30. How many had 30? Good. Our first choice is 3 types of 3 materials, 2 shapes, 5 colors. There's your 30. Number 13. Read that for us, Corey.
A choice your-own combination list allows customers to choose one of each of the following menu options: 6 different soups, 10 different sandwiches, and 5 different beverages.
All right. Pick the lunch special. How many ways could you put this together? Griffin's already got it. These numbers multiply pretty nicely. A lot better than the t-shirt problem, right? Those numbers were a little more involved. Kirsten, how many different lunch combinations can you put together at this restaurant?
300.
How many had 300 different combinations? Good. I would start with the 5 and the 6 to get 30 and then multiply by 10. You just have to slap a 0 on the end. Number 14. Oh boy. We end with a doozy. This will be our last problem of the day, and it's a dilly. Read it for us if you would, Luciana.
Each customer account is composed of 6 characters, 3 letters of the alphabet, a space, and 3 numerical digits in that order. Each of the 3 letters can be any letter of the alphabet except O, while each of the digits can be from 1 to 9.
All right. So, for instance, this customer account for Luciana, maybe it's LUC space 0, 1. You're 13 or 14?
Well,
You're 12. 0, 1, 2. Okay. So this might be Luciana's account. Letter, space, number. Now, there are how many letters in the alphabet, class?
26.
But there aren't 26 letters to choose from because they particularly ban one of the letters from use. They do not let you use the letter. Why do you think they might ban an O?
Because it looks like a 0.
It looks too much like a 0. Okay, so that means the first choice is actually only 25 different letters. The next choice is 25, and the next choice is 25. And then the 3 digits. Well, how many digits are there, class?
9.
No.
1 to 9.
0 to 9. Or did it say 1 to 9?
It said 1 to 9.
Oh, 1 to 9. So this is not a valid. Oh, this is not a valid. You're 12 years, how many months old? 0. No, you can't say 0. She's counting. 9. Okay, so a few more months and then you have another birthday. Okay, so let's just say this is Luciana's. How many numbers are here, class? Could be here. 9, and then here,
9.
and then here.
9.
All right, you see what you got to do. It's going to be a huge number. How many different customer accounts can they create? How many different customer accounts can this company create? And by the way, this limits how many customers they can have, right? Or they have to delete an old account to make room for somebody else. So this is the cap for customer accounts at this company. Raise your hand when you've got it. Or pencil down and raise your hand when you've got it. I have candy for the first one with the right answer, because it's a big old number. It is in the millions.
Ooh. Is this one way to come back to school?
That's what I'm saying.
Just helping wake your brains up, that's all. we've got an answer. Luciana's got an answer. And Corey got it. 11,390,625 different customer accounts can be created there. All right, homework for this evening. Homework for this evening. Page 254, numbers 1 to 19. Page 254, numbers 1 to 19. Like in class, we didn't make any lists, right? So if it says make an exhaustive list, don't do that. Do this, all right?
Be lazy.
Yeah, be lazy. Page 254, 1 to 19, but do not make an exhaustive list like the directions say. Use the fundamental counting principle. Page 254, 1 to 19, you are dismissed.